Hey everyone. So in this video, I want to show how you can use InMode.net within a WPF application. And real quick, just to show what we're going to build here, is have the application running here. It's the salary prediction, which is going to use that salary model that takes in the number of years of experience and predicts the salary that the person should get. So I input number of years of experience, hit predict, and it gives me a predicted salary. So let's go ahead and build this. First, I'll create a new project, and I'll type in WPF. You see WPF app. I'm going to be using the .NET framework here. And I'll do salary prediction as the name. .NET framework 4.7.2. I think that's the latest one. Alright, we have our main window here. I like to split it vertically. So the first thing I'm going to do, we have our grid defined here. And I'm just going to paste in these column and row definitions. This is basically doing is giving me a column initially of 20 that I can use to kind of space things out. Then I do auto, and then whatever space left is going to be taken up. And kind of similar to the rows here. And I'll have some links in the description that go over some videos I use to help me with WPF to give it a lot more details into what we're doing here. So the first thing, I'll use a text block, and I'll put that in the first column and in the first row. I said the text is going to be salary prediction. Let's increase my font here. See, the vertical alignment is center, and as well as the horizontal alignment. That centers everything. Then I'm going to do a grid that column span. And I'm going to have this text span multiple columns here. I have it span 5 columns. And now I'm going to set the font size to 24. Alright, so we close that. I think I need to go inside the grid here. There we go. And we can see what we're working on over here in our preview. Alright, next, do another text block. This is going to go in the second row. It's going to be the first column, and this text is going to be years of experience. That makes our label there. Next, I do a text box where we can input our items in. So it's going to go grid, row, second row, and it's going to go to our second column. I'm going to add a margin. I'm just adding 10 to the left there and 0 to the other sides. I set a min width of my text block here to 30 pixels. Set the vertical alignment to center as well as the horizontal alignment. And I do the column span of just one column. And I need to give this a name so I can refer to it in the code there. And I'll do years of experience. And next I need a button, that predict button there. Let's see. So I give it on the third row and the first column there. I'll center it vertically and horizontally. I set the content of the button equal to predict. Good. And next I need a text block of our results here. So it's going to go on the second row and the second column, and I'm going to center it vertically, but horizontally I'm going to put it on the left alignment, and I'm going to give it another 10 pixels to the left with the margin and give it a name of result. So I know I went through that pretty fast, but we kind of built out that UI that we showed earlier there. And for the code part, we can go into the code behind of our item here. And actually, let's add, for our button, let's add a click event. It says new event handler. I'll just click, hit enter for that. And that adds this button click method to our code behind. And from there, well actually first, let's install InMode.net to the project using 1.4. Next, let me add a new folder, call it ML model. Now put in that salary model here and set it to copy. In our button click event here, we can create a new context. And then we can get our model by using context.model.load. And here's ML model. Salary model.zip. And now output our data view schema as input schema. And next I can create a prediction engine using context.model.create prediction engine. And we need to create our salary data input schema and our salary prediction output schemas. Pass in the model and the input schema. And let's go ahead and create these classes here in a new file. There we go. We have our two model files. In fact, we can create a new folder called models and move those in there. There we go. Now we can create a prediction using the prediction engine that predict. Pass in a new salary data, and in our years of experience need to get what we type in into this text box here, and because we named it years of experience, we have access to it, years of experience, and we get the text from it. But that is a string, so we need to parse that into a float, and then we need to put it into this text box here that we named result. So we can do result.text equals predicted salary is prediction that predicted salary, and I'll do toString to format into currency. There we go. Now let's run this. Get an error. ML.NET currently supports 64-bit, so we can go to our project properties and build. Now unclick prefer 32-bit, and the platform target I set as 64-bit. Good. Now let's try this again. Alright, so we get this type name app does not exist on type salary prediction. This is my fault here. So I named my project salary prediction, but I also have this class called salary prediction, so it's kind of conflicting. So I'll rename this as salary predictions and set that there. There we go. Now we can try again. There we go. Now it runs. Let's see if we get a prediction here. Yeah, so we get this error, unable to load DLL CPU math native. So what that is basically just kind of a bug in this 1.4 version of ML.NET, and it has been fixed already. So we just do include pre-release, and we get the latest 1.5 preview 2. We just upgrade to that. Alright, now we can try again. There we go, and I've kind of messed up a little bit on my UI here, but you can see salary, we get a salary prediction. Let's see if we can fix that. So instead of putting column 2, I need to put it in column 3. So just to make sure that that works. There we go. And it calls into our model and we get a prediction. Generally, now for small applications, this is probably okay, where we just bind a click event into our code behind of our UI here. But you notice we create a context, load the model, and create a prediction engine every time we click this predict button. So is there a way we can do better? We can just do this once within our application. And in fact, there is something we can do. We can use an MVVM framework to help us with this. And the one I'll be using is Caliburn Micro. There are several of them out there, so feel free to experiment with all of them, see which one that you like. I'll get the latest release. I'll just bring in Caliburn Micro as a NuGet project. There we go. And for Caliburn Micro, there's a few things you need to do for it to work. And again, I'll have a video down below that helps with this stuff as well. The first thing in your app XAML, we need to add in some stuff here. We need to add in a resource directory, and we need to tell the user Bootstrapper. This kind of warning here says the name Bootstrapper does not exist. We need to create that class. So add a new class, call it Bootstrapper. See, I'll make it public. And then I'm going to inherit from Bootstrapper base. And this comes in from Calibre Micro. And in here, the space gives me a few methods that I can actually override. So we'll do protected override on startup. Alright, now bring in these startup event args. And for our on startup that we're going to override, we're going to say display root 4. And in here, I need to give it a view model as the type. So I'm going to say startup view model. And let's create another folder called view models. And we are implementing that MVVM model view model pattern here. So we have models, view models. Let's create another folder called views. And our view models will add a class, startup view model. And let's go ahead and create a new window for our view called startup view. And let's see, in our main Windows XAML, I'm just going to copy everything that we did here inside our grid. And I'll paste it into this view model. There we go, so we get the same UI here. And in fact, I am going to delete this main window because we don't need it anymore. And that's because we specified in our on startup, we display this startup view model. And Calibre Micro knows this startup view model matches to the startup view because the names kind of match there. And then one last thing, in our app XAML, it says a startup URI. We'll just delete this. Otherwise, it's going to continue to look for that main window. Alright, let's run this. Make sure this runs okay. Continue method for button click. Let's remove that. Okay, let's try this again. Alright, so we don't have anything here. I think I forgot in our Bootstrapper we need to put in a constructor and say initialize. There we go, so that should work. There we go. So it starts up, the startup view is our initial window, but if we try to predict, nothing happens now. So let's go back to our startup view model. We'll make this public. And if you're familiar with MVVM, you have properties for kind of the items that you want to interact with. So in our case, we interact with this button and this text box to display our results. And then this text box to get the data for our prediction when we click the button. So let's make a few properties here. First, let's make a full property for our years of experience text box. Experience. Yep. And then another one for the result. So I'm going to move my private variables up here. The way Calibre Micro works is that it's going to match these property names to the names of our UI elements here. So our years of experience, we need to change that to match. And the same with our result. There we go. So if you want to, for instance, let's update this result, all we have to do is we update this property and Calibre Micro does the work for us to automatically hook into this text box, so this text box will update. Alright, so that's the text box. So how do we hook up this button click here? And this button kind of works the same way, so we need to give it a name, and we call it predict. And back in our view model, we give it a public void predict. It's a predict method. And then here, let's do just that result equals just that years of experience, just to kind of show this that this is all working. Good. And let's breakpoint into here just to prove that it is going in there. I'm going to hit predict and go. So it hits the breakpoint. It has the number of the years of experience. But if I continue, notice we don't get an update in our UI here. That's because we need to tell the UI that this result has been updated. And to do that, in our set here, we need to use the notify property changed method, and it's going to take in a function which we can use a lambda expression, and we just say this dot result. To get that, I need to inherit a screen from Calibre Micro. Actually, it's called notify of property change. There we go. So now when I run this, the UI knows that the result has been updated and it reacts accordingly. Alright, so now we need to run the ML.NET in this predict method. But like I said before, we don't want to create the context or prediction engine pool every time we hit this. So what we can do is we can do something called an IOC container, which handles dependencies for us. And to do that in our Bootstrapper, we need to create a new field here called simple container, and I'll call it container. And simple container comes from Calibre Micro. Set it to a new instance of the simple container. And we have some more overridable methods here that helps us use the simple container. So we protected get instance. It's going to return the container that get instance. Pass in the service and the key. Next will be protected override get all instances. It's going to return the container that get all instances. Pass in the service, and I need to do protected override build up, which is going to call container that build up. Pass in the instance. The next protected override void configure, and in here this is where I configure my services that I want to be injected. So I do container that singleton, means I want a singleton of a type. I do window manager and pass in window manager. I do the same for event aggregator. Pass in event aggregator. Now the reason we need to do these two is I think WPF relies on these two to work appropriately. And then next I need to create an prediction service and then pass in a prediction service class. And last, on our container, we need to register per request, and this just hooks up our view models to our container. So I do type of startup view model, pass in null as the key, and then I'll do type of startup view model again. So let's create this interface first. It's going to return a salary predictions, and it's going to have a method called predict, and it's going to take in a float years of experience. And let's create this prediction service. It's going to inherit from prediction service, and I'll tell Visual Studio to implement the interface. This is where we can call our context and all that. So first I want to do a private read-only prediction engine. It's going to be salary data and salary predictions. Call it prediction engine. And then in my constructor here, this is where I create a new context. This is where I load my model, and then I'll set this prediction engine equal to context.model.create prediction engine. Just copy these over, pass in the model and the input schema. There we go. And in our predict method here, I can just return prediction engine that predicts new salary data, and just send the years of experience equals to the years of experience that we pass in. Alright, so almost done in our startup view model now. I can get rid of this and say prediction equals prediction service that predict, and do float that parse this that years of experience, and then this dot result is going to be prediction dot predicted salary dot toString. There we go. But where do we get this predicted service from? So to do that, we create a constructor. Because we registered that item in the container, we get an iPrediction service into our constructor as a parameter. A private read-only iPrediction service field here, and I'll just set service equal to prediction service. It says iPrediction service is less accessible, so instead of internal, I'll just do public. Let's run this, make sure everything runs okay. Build errors. Let's make these public instead of internal. Alright, so give it 8 years of experience. There you go, and we still get our predicted salary. That's kind of just a brief introduction on how you can use ML.NET within a WPF application. And I know we use a simple model. I'll probably do another video on how you can use an Onyx model for image classification or something like that. But I'll end things there. I hope you enjoyed the video, and thanks for watching.